Fresh images of 3I, Atlas, the third interstellar object ever observed from Earth, had just arrived. And they are unlike anything astronomers expected. What should have been a faint, chaotic ball of ice drifting quietly toward the Sun has now become one of the most unsettling mysteries of modern astronomy. At the end of August, Chile's Gemini South telescope was trained on Atlas. Scientists anticipated confirmation of the obvious, a dusty halo, a hazy tail, a comet slowly shedding frozen gases as it approached the heat of our star. Instead, they saw something that made even seasoned astronomers hesitate. The comet's tail had changed. What had once been a messy, drifting plume of vapor now stretched outward like a luminous spear. It was sharp, bright, and unnervingly clean. Not random. Not chaotic. But precise. In its official statement, the observatory described the tail as significantly more extended, but those words barely capture the truth. The tail wasn't simply growing, it looked engineered, stretching in stages like an exhaust plume. A direction, not just a drift. And its alignment? Toward a path that will take it alarmingly close to Mars. Ordinary comets don't do this. Their tails twist and bend under the force of the solar wind. They fracture, they wobble, they scatter. But Atlas seemed almost disciplined, as though it was scaling itself deliberately, holding a form no natural comet ever has. That led to a question few wanted to ask out loud. Was this natural sublimation, or was this control? Harvard astrophysicist Avi Loeb suggested something bolder, that the tail itself could be functioning as thrust. Not a byproduct of ice melting, but a signature of propulsion. In other words, less like a comet and more like an engine. Then came Webb's contribution. The James Webb Space Telescope recorded a massive plume of carbon dioxide enveloping the comet, an astonishing 350,000 kilometers across, nearly the distance from the Earth to the Moon. Yet the plume didn't behave like a cometary exhaust should. Solar wind pressure should have contained it long before it reached that size, and still, it stretched too far. Worse, it was still too small to explain what would be needed for Atlas to maintain its razor-sharp course through the solar system. It was both too much and not enough. Chaotic, yet impossibly stable. And then, another revelation, one that shook confidence even further. The nucleus of Atlas wasn't shining because of exotic ices, as many assumed. Its strange brightness came from metal. Nickel. Not in faint traces, but in amounts consistent with industrial alloys, the kind humans use for spacecraft, plating, and machinery. No comet ever observed has displayed this kind of reflective metallic surface. Nickel is durable, resistant, and highly reflective. It explained why Atlas glowed so steadily. But it also raised the possibility no one could ignore. Was this a natural body, or something reinforced? Something built to endure? This nickel mystery has ignited speculation across the scientific world. A comet with an alloy skin, a hyper-stable trajectory, and a tail that looks like thrust, each detail could be explained away. But together, they begin to suggest something more unsettling. Something not made by nature. And the timing makes it worse. On October 3, 2025, Atlas will brush past Mars at just 29 million kilometers. In cosmic terms, that's a razor-thin margin. Its minimum orbit intersection distance, 2.7 million kilometers from Mars's orbital path, has been described as a cosmic bullseye. To have an interstellar comet thread through space with that kind of precision is almost unthinkable. It should not happen by chance. NASA is preparing its Mars Reconnaissance Orbiter for the encounter. Its high-rise camera will capture Atlas in extraordinary detail, able to distinguish features as small as 30 kilometers across. For the first time, humanity may see an interstellar nucleus up close. But what if the images reveal more than ice and dust? What if the nucleus carries edges, panels, or symmetry, fingerprints of design? And what if Atlas makes even a small course adjustment in the weeks before October? Outgassing cannot account for changes of 10 or 15 kilometers per second. Yet that would be enough to place Atlas directly in Mars's path. That would not be the move of a comet. That would be a maneuver. On October 30th, just before Halloween, Atlas will swing closest to the Sun, its tail blazing across the sky. Days later, it will pass Mars, where orbiters and cameras will watch its every move. If it is natural, it will be a spectacle unlike any before. A comet from another star system captured in detail. But if it is not, if its tail is thrust, if its surface is alloy, if probes emerge from its glow, then this will not be the story of a comet at all. It will be the story of first contact. And right now, humanity waits in suspense, watching the luminous spear of Atlas cut deeper into our skies, wondering whether we are witnessing ice melting in the void, or a machine approaching with purpose.